Good morning or good afternoon, whenever you're seeing this. Good evening to you guys. I miss you guys a lot. Just needed to take a day just to kind of, go through the grieving process and stuff like that. I know you guys will understand. I did want to walk you through the Delta Math, a couple of problems. So the first topic and the last topic are non-negotiables, like you have to do them. The middle topic, there's three of them on Delta Math. The middle topic is the one that if you watch the video and you show me that you tried it, like at least watch the video and try one or two questions. If you don't get it 100%, that's okay. But the first topic and the last topic, I need you guys to work on. I'm going to walk you through as much as I can of it. So the first one says, this is just some sample problems that you're going to see in the first one. Write the expression in exponential form. So all that means that you do is, let's just go over a couple of like words real quick. So this is called, the 5 is called the radical. It's the 5th root. The 4 is called the exponent. Let me do that in purple. I'm going to put like a little triangle there. And then what you see right here with the x, that's called the base. Okay, so radical in blue, exponent in purple, which you guys all know, and the black is called the base. Okay, so all you have to do is, it's basically taking those expressions, right, that's there, or those terms, and then you're going to go ahead and write it in exponential form. So all that means that you do is you take the base and you put it on the bottom, right? The base goes on the bottom, okay? The next thing that we want to do is exponents go on the top. I'm going to change my color to purple. So you're going to write it as a fraction with the exponent, this 4, right, on the top. The radical, right, is called the root. So rad is root. And roots, think about like plants. The roots go on the bottom, right? When you have plants, the roots go into the ground, right? So this right here is our final answer, x to the 4/5 power. And all I did is I took it and I rewrote it. Okay, we're going to do a couple more. Before we go ahead and do another one, I'm going to go ahead and go backwards, right? So x is our base. So I'm going to write my base. I know at some point there is going to be a radical. So I'm going to put my little radical symbol. And then I'm going to remember that the 2 is my exponent. So I'm going to put it, I could put it here or I could put it over here. We'll talk about that in a second. And I know that my 5 is the base. What did I use for my, the 5, not the base. The 5 is my radical. I use blue. So this right here is my radical. So I'm going to put the radical, aka the root, and that little like hook, whatever you want to call it. Okay, so it's going to be the 5th root of x to the 2nd power. I mentioned this before. This is exactly the same thing as if I wanted to write the 5th root of x to the 2nd power. These two expressions are the same thing. Okay, so please take notes along with me, so you have a couple of ideas before you start your actual lesson. We're going to do another one real quick just to make sure. And I'm just going to do it in one color. So my x is the base, so I'm going to write it down, right? That's boop. The 5 is the exponent, so I'm going to write it on the top because exponents go on the top. And my 6 is the radical or the root, and that's going to go on the bottom. Some people call it an index or indice, depending on preference. Tomato, tomato. Okay. We're going to skip this for now. So this is the second topic. I'm going to pause on that. I'm going to go to the last topic. So the last topic, you're going to see questions like this. Remember, I told you on Delta Math there are 3 topics. First one and last one are non-negotiables. Do those first. The one in the middle is like maybe a little bit harder. It's just a little bit more complex, but you guys can get it. It's just you might need a little bit more exposure. Okay. So I want to remind you, I'm going to do a quick commercial break. Refresher from Algebra 1. If you have x to the 2nd times x to the 3rd, if the bases are the same, you take the exponents and you add them. So that's going to be x to the 5th. I also want to remind you that if you have like a power to a power, like x to the 2nd, it's go ahead and do it a little bit better. If I have x to the second, all raised to the third power, if you have a power to a power, right? You're taking one power and you're raising it to another. That's when you multiply them. 2 times 3 is equal to 6. And the reason why is because if you have x to the second, to the third power means that you have 3 of those same expressions when you're multiplying with the same base, just like rule number 1, you add the exponent. So 2 plus 2 is 4, plus 2 is equal to 6. So that's going to be x to the 6. So this, like I said, is just a quick commercial break. Doot, doot, doot. Okay. So getting back to our problem that we have at hand, we have x to the 1/3 times x to the 3/2 is equal to x to the a. I'm just going to work with the left side, just that right there. I'm going to kind of continue it down. So remember, when you're multiplying with the same base, what do we do with our exponents? We add them, right? So we're adding 1/3 plus 3/2 together. 1/3 plus 3/2. For those of you that are like, Miss, how do I do that, right? You can use your calculator to help you, but I want to refresh your memory, especially for if you're taking an SAT. I don't really care about a test, but like, you should know at some point in your life how to add fractions, even if it's like to help your kids with it. So 1/3 plus 3/2, and a lot of us hate fractions. It's okay. What you do is you look for the least common multiple. So the multiples of 3, 3, 6, 9, 12, blah, blah, blah. Multiples of 4, 2, 4, 6, blah, 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 blah. The one that's the smallest in both of those that I just said is 6. So we're going to take the 6 and put it on the bottom. That's our LCM. And then to get the 3 to be a 6, you multiply it by 2. Whatever you do to the bottom, you do to the top. 2 times 1 is equal to 2. You do the same thing here on this side. To get from 2 to 6, you multiply by 3. We always do multiply, divide, not add and subtract. So whatever you do to the bottom, you do to the top. 3 times 3 is equal to 9. And now you just add it as regular. 2, 6 plus 9, 6 is 11 over 6, not 12, right? We have to go ahead and keep the same denominator. So it's 11 over 6. So our final answer right here is going to be x to the 11 over 6 is equal to x to the a. And now all it is just matching. You're like, let me go ahead. I used that already. Okay. I used that already. Let's go ahead and use some blue. So we have x to the some number, this happens to be 11 over 6, is equal to x to the a. So all I'm asking you right now is, what is a, right? So a is the exponent, and the exponent here is 11 over 6. So that means that a is equal to 11 over 6. Final answer. Okay. We're going to do another one. This goes back to what we said about if you have a power to a power, you multiply them. So here you have x to the 2/3 to the 5 over 2. So we're going to multiply 2/3 times 5 over 2 is equal to x to the a, and we're just going to like match it again. But before we can do that, we want to figure out what this 2/3 times 5 over 2 is equal to. A reminder, when you're multiplying fractions, you do top, top, bottom, bottom. So that's going to be x to the 2 times 5 is equal to 10. And 3 times 2 is equal to 6 equals x to the a. This is not your final answer because I'm going to highlight, it says in simplest form. So 10 over 6 can be reduced. Remember that 2 goes into both of them. So 10 divided by 2 is equal to 5, and 6 divided by 2 is equal to 3, is equal to x to the a. And our last step is just asking you, what is a? We don't care about what the whole thing is. So a is just a matching, right? A is the exponent here. So the exponent here is 5/3. So final answer, a equals 5/3. Right? So those are the two that you must do. And we're going to go back to the ones that are a little bit more like Miss. What? So a couple of things just to keep in mind. Number one, there is if you have your calculator, whether it's an app, there is a function in the calculator that will help you like figure this out if it's like multiple choice. So I have 64 to the 1/3 power, so I can go 64 to the, right, hit the little mountain symbol, to the 1 divided by 3 and I want to hit enter and I get 4. And the reason why this works, we're going to talk about why, because the calculator can give you an answer, but we want to know why. So the reason why goes back to what we did before it, like in the first problem, right? So 64 is our base, so you're going to write 64. 1 is our exponent, so I'm going to write to the first power. 3 is our, remember, what is it? It's our radical. So I'm going to have the cube root of 64 to the first power. So you guys know any number to the first power is just itself, so I can simplify this to be 64 to the first is just 64. Let me close that. That looks weird. And then I'm going to do the cube root of it. So what cube root means is I'm looking for a number that when I multiply by itself 3 times gives me 64. So think about it. 1 times 1 times 1 is that 64. Nope. 2 times 2 times 2. 2 times 4 is, noops. 2 times 2 is 4. 4 times 2 is 8. That is not 64. So that doesn't work. Eventually you'll get to the point where you're like, oh, it has to be 4. Because 4 times 4 is 16, and 16 times 4 is 64. So our final answer is going to be 4. Okay? That one should be pretty straightforward. This one here gets a little bit more complicated, so I'm going to ask you to hear me out. Okay? So first thing we're going to do is we're going to rewrite it. So 8 is my base. 4 is the radical or the root. And then 3 is my exponent. So I'm going to put the 3 here. Okay? So for these types of problems, the easiest thing to do is to go ahead and write down the cube roots. So what I mean by that, let's go ahead and take a little bit of a break. What I mean by that is 1 times 1 times 1 is equal to 1. 2 times 2 times 2 is equal to 8. 3 times 3 times 3 is equal to 27. 4 times 4 times 4 is equal to 64. We just did that. 5 times 5 times 5 is equal to 125. 6 times 6 times 6, I don't know, whatever. You get the point. Okay. So we're going to go ahead and I should probably just do one more. I'm using my calculator. 6 times 6 times 6 is equal to 216. So 6 to the third is equal to 216. And again, you can keep going. All right, so for this problem right here, what we want to do is we want to evaluate this, right? So the fourth root of 8, is there a number that when you multiply by itself 4 times gives you 8? 1 times 1 times 1 is, sorry, 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 16. That's too big, right? So you can't really simplify if it's just the fourth root of 8. So what we want to do is we want to do 8 to the third power. So 8 to the third power is 8 to the third power, right? Is 8 times 8 times 8 is 512. So we want to rewrite this as the fourth root of 512. And so now we have something to go by, okay? So the easiest thing to do is to look at these numbers that we wrote on the right hand side, pick the biggest number and see if 512 goes into that. So what I mean by that is this: you just go 512 divided by 216 is, if we keep going, 216, and we see if it gives us a whole number. Nope, right? So it doesn't go into 216, like it doesn't go into 6 to the third. So then we go ahead and do 512 divided by 125 is our next one. Nope, that's not a whole number. And then let's try 64. 512 divided by 64. And boom, there we go, right? So now we have a whole number here. So we know the best numbers to use. All right, so let's go back a little bit. So in the meantime, while I was clicking out of this, I was like, wait, why is this, something's off? And the reason why is because this is the fourth root, right? So if it's fourth root, you're doing exponents to the fourth power. So 1 to the fourth power is 1, 2 to the fourth power is 16, 3 to the fourth power is 81, 4 to the 4th power is 256, 5 to the 4th power is 625, and so on. Okay, so what we want to do is we want to take a look at 512 and see numbers that like see if 625 is a factor of 512. And obviously it cannot be, because 625 is bigger than 512, so that's definitely out. So let's go ahead and test 256. So what I mean by that is we go 512, calculator, we do 512 divided by 256, and same thing, we're looking for a whole number, and boom, it is, because 256 doubled is 512. So the best factors to use, like you could have used other ones, but using 256 will help save you a lot of time. So 512 is equal to 256, the 4th root, times 2, the 4th root of 2.
Stay quiet.
Okay. So now the reason why this is the best number to use is because the 4th root of 256 is equal to 4. So if you do the 4th root of 256, your final answer is just going to be a 4. Done, right? This 4th root of 2, can't even speak today, cannot be simplified anymore because 2 is already a prime number. So our final answer is going to be 4 and the 4th root of 2. Done. So watch this part again. Make sure that you're good with that. I'm going to go through a couple more. So this one right here, right? So we have this 72 to the 1/4 root, 72 to the 1/4 power. So we're going to write 72. The 1 is our exponent. The 4 is our root. So you write it like that. Any number to the first power is just itself. So you write 72. And then we're looking for the 4th root of that. Okay. So we already did 4th roots up here. So I know that there's no way that 625 is going to be a factor. There's no way that 256 is going to be a factor. There's no way that 81 is going to be a factor because 81 is bigger than 64. So I'm going to go back and let's try 16. And yeah, let's see. So let's try 16. So what I want to do in my calculator is do 72 divided by 16 is equal to 4.5. So that didn't work, right? Because that's not a whole number. So then we can keep looking and we could say, oh, 1. So what that means is if none of those numbers go into it, that means that even if you try to figure out what numbers go into 72, like 36 times 2, you'll see what happens. So let me go through it this way if you didn't realize it. 36 is equal to 6 times 6, right? And that's 4th root, 4th root. This one's already done, so I'm going to circle it. This one can be broken down into the 4th root of 2 times the 4th root of 3. This is done, and this can be broken down into the same 2 and 3, the 4th root, the 4th root. This is done. So what you're doing now is you're looking for groups of 4, right? Because our radical is 4. This has a group of 2, a group of, here's a 2, a 2, a 2, but that's not 4 2's. So you can't simplify it further. If there were 4 2's, then you can go ahead and say that's a group of 4 2's, and then you can cancel it out and just put a 2, like a 2 comes out. This one right here, there's a 3 and a 3. There's no 4 3's, so I just have to leave my answer as is. So the final answer for this question is the 4th root of 72. And the reason why is because when we came back here, none of these numbers, the 1, the 16, the 81, the 256, 625, went into 72. So you leave it as is. Okay. The last one we're going to go over together. Oh, we did all of them. Okay, cool. So use this video, like I said, for the second topic, just watch the video and then do it that way. You should be fine. And then the first and the third ones are the ones that are non-negotiable in Delta Math. You guys should know what I'm talking about. In Delta Math, there are 3 topics, right? The first one and the third one you must do, right? We just went over it. That's mostly a review of Algebra 1 with a little bit of Algebra 2. For this one right here, for the second topic, which is the one that we're doing, that looks like problems like these, express this in simplest radical form, so on and so forth. Those are the ones that I'm just going to ask you to watch the video. Okay, I watched the video, try a problem or two. You can try to stick with it. So a lot of you guys will get it, but I know it's going to be like for some of you. Okay, thank you. I love you guys. Talk to you soon. See you next week. I'll put grades in by Saturday.